Karibu sana katika kipindi chetu cha Chemistry Practical, na leo niombe kwamba tuweze kuwa pamoja, tuweze kujifunza kile ambacho nimekuletea hapa, na Ninaimani unaona hapo ubaoni kwamba nimekuletea issue ya double indicator. Double indicator will mean we are going to use both indicator, methyl orange and phenolphthalein indicator. And for today we have double indicator in case of part 1, and tutaenda kujifunza tudhari natumia lugha zote mbili kwa sababu ili uweze kunielewa kwa uzuri kabisa. We have the mixture of sodium carbonate and the sodium hydroxide against hydrochloric acid. In case of double indicator, we're going to use, we're supposed to know which indicator is first to be used and which is going to be used at the end of the reaction. The indicator used is POP. The first indicator to use is POP. The first indicator is POP because when we use the methyl orange, it means we tend to complete the reaction totally in a conical flask under the mixture of this one and the sodium hydroxide. So it means when we start with the POP, we get intermediate of the weak base, which is sodium hydrogen carbonate, which will be supported by methyl orange. So when we use methyl orange at the first, it means there was no a chance of using phenolphthalein indicator. So we're supposed to use POP in order to get another intermediate base which will be supported by methyl orange. But when we start with this one, the color change of the titration will change. It means the color change from pink to colorless. When we reach at the colorless, it means there was a chance of using methyl orange without discussing the solution of the first titration. It means you're supposed to add. Then here we add 2 drops of methyl orange indicator. That is the case and the format of titration under double indicator. It means sodium carbonate and this one will be at the conical flask or in the conical flask, and the hydrochloric acid will be in the burette or at the top within the burette. It means the conical flask here the first indicator will be POP, and at the end we are going to use methyl orange. That is the system of performing titration. Then after the titration, what's the reaction being released under the titration or under the experiment of today? It means we have the sodium carbonate is going to react with hydrochloric acid. Then under POP, we have said under POP at the first iteration, it means you are going to get sodium chloride plus sodium hydrogen. We are going to get this one. This is aqueous solution. Aqueous also, this is aqueous solution. That is first experiment. the second reaction will be this intermediate will react twice. It means to complete the reaction, it means we are going to put, in order to then sodium hydrogen carbonate will react also hydrochloric acid aqueous solution. Then we are going to complete sodium chloride plus carbon dioxide plus water, liquid gas aqueous solution. That is the second reaction. So the third will be, and this will be reacting with methyl orange. So in order to complete this reaction, we are supposed to add methyl orange. And the third reaction, sodium hydroxide, will react with hydrochloric acid. We get sodium chloride plus water. That is the third reaction. So, and this is under POP. That is POP, or phenolphthalein indicator. So you will see how many indicator, how many POP used, and how much methyl orange used. It means phenolphthalein indicator within titration used twice. It means used to complete this one, sodium hydroxide to neutralize, and used to neutralize sodium carbonate to get intermediate, which will be completed by using methyl orange. That is our reaction. So after this one, we wanted to see which volume of hydrochloric acid used to complete this one and to complete this one. We want to see the volume of hydrochloric acid to neutralize this one. Sodium carbonate means sodium carbonate from here up to here. This is sodium carbonate. It means from this one intermediate up to here, the complete of the reaction is this one, the second question. So let's be together here. You still be together here, then you'll understand more our lesson for today. So the volume of hydrochloric acid to neutralize sodium carbonate, we have seen that sodium carbonate reacted twice by using hydrochloric acid. The first sodium carbonate release this one under POP, and in order to complete, we have get sodium chloride plus water plus carbon dioxide. It means this one was hydrochloric acid, and here was sodium carbonate, but this one was hydrochloric acid, intermediate hydrogen carbonate reacted with hydrochloric acid. I think you will see hydrochloric acid used twice. It means 1, 2 to complete sodium carbonate. So how many volume of hydrochloric acid would be calculated? Because sodium carbonate used twice, it means the volume of acid, the volume of acid to neutralize hydrochloric acid is equal to, we take the volume we have got under using methyl orange, we take under methyl orange the volume times 2. That is how to get the volume of acid used under methyl orange, under the mixture of this one against the hydrochloric acid, and not the other double indicator question. That is one. And the volume of hydrochloric acid used to neutralize the sodium hydroxide, it means we take the volume of POP, we remove the volume of methyl orange we have got before times 2. Before times 2. Because sodium hydroxide reacted once, in order to get the volume of hydrochloric acid reacted to neutralize with this one, we take, it means the volume of hydrochloric acid to neutralize this one, we take average volume of POP minus average volume of methyl orange. That is our formula of getting the volume of hydrochloric acid to neutralize sodium hydroxide. Let's see the example of this one. Assuming that you prepare this one, you prepare 0.05 of sodium carbonate, and we add the mixture, or we are going to mix with the 0.05 of sodium hydroxide. Then we are going to react by preparing 0.1 molality of hydrochloric acid. Which volume will be used of the acid to neutralize sodium carbonate and the sodium hydroxide? When you prepare, actually, let's see which volume will be standardized first. So we remember that our reaction, we have 3 reactions. The first will be this one. It means sodium hydroxide is 0.05 m under 1 liter. Sodium carbonate is 0.05, but hydrochloric acid is equal to 0.1 molality. So what is the volume of acid will be used here and here? Under the standardization, you are supposed to see, it means the first reaction is this one, sodium carbonate and then hydrochloric acid. Then there is a product. The second, there is sodium hydrogen carbonate plus hydrochloric acid. Then there is a product. The third was sodium hydroxide plus hydrochloric acid. Then there is product. So when you want to know the volume of used, you're going to use, it means volume of acid is equal to molarity of acid, molarity of base, volume of base, number of acid over molarity of acid, volume of number of base. It means molarity of acid is molarity of base 0.05 times 25. Our pipette is 25 times 1 for here, divided by 0.1 times 1. Actually, you will see the reaction or the volume will be, it means 0.05 times 25 divided by, it means will be 12.5. That is volume over here. It means the volume over here will be 12.5. And this one, because our ratio is 1:1, and here the volume will be 25 under titration. But when you complete the reaction, here will be 2 more. So when you equate from this equation or our formula, it means VA is equal to 0.05 times 25 times, this one is 2 over 0.1 times 1. Almost will be 25. It means 0.05 times 25 divided by 0.1 times 2 means here will be 25 volume. That is our volume. So it means under titration will be this one, the volume, this one. This is volume. So in order to get the volume of acid at each reaction, we are going to use our formula as I have shown there. It means the volume of HCl, we have said sodium carbonate reacted twice. It means here there is POP, here is MO, and here is POP. It means in order to get the volume of methyl orange of hydrochloric acid used to neutralize sodium carbonate, it means we get for methyl orange we have get 12, means 12.5 times 2 is equal to 25. That is volume of hydrochloric acid used to neutralize sodium carbonate. The volume of acid to neutralize sodium hydroxide, it means we take this one, total volume for POP. It means POP used here up to here. It means we take this one, then add this one. It means we take 25 minus 12.5 is equal to 12.35. It means the volume of acid for this one is equal to 25, and the hydrochloric acid for sodium hydroxide is equal to 12.5. That is on how can you calculate the volume of hydrochloric acid for the double indicator of sodium carbonate and sodium hydroxide against the hydrochloric acid. And for today we end here. We meet another session. Thank you for listening me. Then I beg you to click that video you see there at the end of the lesson. We'll come again share this knowledge, subscribe. We'll be together more and more. Thank you.